What's up? This is Randy. It is time for us to learn how to graph and transform the graphs of exponential functions. Here we go. So today, before we get into exponential functions, we're going to talk really quickly about one more special case of square root and cube root graphs, that is a negative a. And then we'll talk about the transformations of exponential functions. And then, as usual, we'll finish with some examples. Okay, one more note on square roots and cube roots. You've seen this graph before of the square root of x, and you've seen this graph before of the cube root of x. But what happens if the value for a in the square root of x or the cube root of x is negative? How will that affect the graph? Let's say that we had -1 for a. So that would make this function the negative square root of x. And if we had -1 for a for the cube root of x, that would make it negative cube root of x. What would that look like? Well, that would just render a vertical reflection. We will always reflect over the starting point of a square root graph, which in this case happens to be the x-axis, or we will reflect over the point of inflection on a cube root graph. And lastly, just as your intuition should tell you by now, if a is less than -1, such as like -2, that would render a vertical stretch of the graph. And if a is between -1 and 0, that would render a vertical compression. So keep that in mind. Now let's talk about exponentials. So here's our formula for an exponential function, and here are the rules that the transformations will follow according to the variables. So I encourage you to pause it now and try your best to absorb this information, and then I'll make a few quick points before we get into some examples. All right, first of all, let's talk about the sign of a. If a is positive, the graph will not be reflected vertically, but if it's negative, it will be reflected vertically. You'll see an example with a -a. And one more thing to keep in mind is that for this lesson, a will only be +1 or -1. Now think about this. If a is negative, over what line is the graph being reflected? It's being reflected over what we call the asymptote. Technically, a straight line that continually approaches a given curve, but does not meet it at any finite distance. And in this lesson, all of our asymptotes will be horizontal. And finally, the shifts are the same as the shifts that you've seen in recent previous videos. So -h is a rightward shift, +h is a leftward shift. So those are kind of counterintuitive. And then +k is upward, which is more intuitive, and -k is downward, which is also more intuitive. Lastly, in this lesson, you will be given a value for b in each problem. It will typically be a relatively small integer, and it will remain constant within a given transformation. All right, enough said. Let's do a couple of examples. So here is our guide that we just talked about, and we are asked the question, the equation of the green curve, f of x, there it is given below. What could be the equation for the blue curve, g of x? And we have to choose between these four options. So we are given the function f of x equals 2 to the power of x. And I see that we have a horizontal asymptote at 0. And then in the next function, it is at -2. But let's talk specifically about what is an asymptote exactly. An asymptote is an invisible horizontal line in this case. There are asymptotes that are vertical or diagonal, but in this lesson, we'll be looking at horizontal asymptotes. That the graph continuously approaches forever. You can see that right here, it's 1.5 units from the asymptote. Right here, it's a little bit less than 1. Right here, it's like half a unit from the asymptote. So the graph continuously approaches the asymptote, but never touches it and never crosses it. So if you zoom in on the graph like crazy, where it looks like the graph is touching the asymptote, you'll see that it actually does not ever touch the asymptote. It just continues to get closer and closer and closer. Now what's nice is that the asymptotes tell me very specific information about the value of k. What do they tell me? What was the vertical shift of the graph? Well, 2 units, right? It was shifted down 2 units. So that tells me that k, in this case, is -2 for g of x. So we know that A could not be the answer. So we're stuck choosing between B, C, and D. So there was no reflection that happened, so we just need to figure out what is the value of h. Is it -3, +2, or +3? Well, we know that going from f of x to g of x, we definitely moved to the right. That's quite clear. So that tells me that we're going to have minus something because minus h is a rightward shift. So we could not have +2 or +3 because both of these indicate a leftward shift. So the only possible answer is B. Okay, now don't check out yet because I want to show you how we can know that it is exactly -3 and not something like -4 or -2, okay? So keep listening closely. All we have to do is identify a corresponding point between f of x and g of x. How could we identify a corresponding point on both graphs? Well, what you could do is just go to the asymptote and then find the first point on the graph that is exactly 1 unit above the asymptote. So what point on this graph is exactly 1 unit above the asymptote? Obviously, 0, 1. That point right there. And what point on this graph is exactly 1 unit above the asymptote? Well, obviously right here. That would be 3, -1. 3, -1. Now it's easy to see the horizontal shift because we have 2 corresponding points. We just shifted 1, 2, 3 units to the right because horizontally, those 2 corresponding points are exactly 3 units apart. All right, there you go. Now you know why it was exactly -3. All right, now let's do an example that involves reflection. So we are told that the green curve is f of x equals 4 to the power of x. So this curve right here. And it is obviously reflected vertically. So that's going to make A negative. So this is like saying -1 times 4, -1 times 4, -1 times 4. So in those 3 options, A is -1. So because we have a reflection, I know that B cannot be the answer because this right here has a positive A. So now let's think about the vertical shift and the horizontal shift in order to choose between A, C, and D. So I can see that our asymptote was shifted 1 unit down. So that means that we have -1 in place of plus K. And here we have a +1, so that means that A could not be the answer. Now, is x minus h, x minus 2, or x plus 2? X minus 2 indicates a rightward shift, and x plus 2 indicates a leftward shift. And as we shifted from this green curve to this blue curve, we obviously went left, so that would make the only possible answer D. Now, looking at the graphs, how can we exactly identify those 2 units? Well, we can still find a corresponding point on both curves. So here is a point 1 unit above the horizontal asymptote on f of x, and here's a point 1 unit below the horizontal asymptote on the blue curve because we reflected. And now we can see that the horizontal distance is 2 units. So we can now be absolutely sure that the answer can only be D. All right, now that we all know what an asymptote is and that we have discussed all of the different types of transformations that we could see in this lesson of exponential functions, we are finished. See you next time. Hey.